Hello, I'm going to go through some information about one proportion hypothesis testing, and then we're going to work through some problems. So to start out with, most of what I'm going to cover is stuff that we've already covered in a couple different places over the course of the semester. So this is just kind of like combining some pieces together to kind of come up with one coherent package of what we're really doing. So these are the steps that if you follow, you should be able to get your way through one proportion hypothesis testing when you're doing it by hand. So first of all, check any necessary assumptions. So the sample observations are independent. So do you remember when you took the quiz and you had to decide whether or not the samples were independent or dependent? And so for example, if something is randomly collected, it's going to be independent versus I think I remember a couple of questions about like if you go to the Republican National Convention and you ask people certain questions while the other people are standing there and you're not randomly selected, well, that's dependent. Okay, so there's your independent versus dependent. So you need to make sure that they are independently sampled. In most cases, we do assume an independence unless otherwise stated in the problem. So in general, we'll just assume independence unless there's something specifically mentioned in the problem that lets you know it's definitely not. The other one is that we expect to see at least 10 successes and 10 failures in our sample. So how you check that is right here, these two little formulas where n is the number in your sample and the null value is what you're testing it against. Now this will be a decimal, not a percent, because the null value is going to be a decimal here. So you just multiply your sample number times your null decimal, and hopefully it should be greater than or equal to 10. And then the next thing you need to check is if the number, the sample number, is times 1 minus your null value. Once again, that's the same null value as up here, is greater than or equal to 10. Now that probably doesn't make a lot of sense here, but once we get to a problem, it will. You also write the original claim. So as you're going through the question, you write out what the original claim is, and then you state whether or not it's the null or the alternative hypothesis. Now this is really important, and I went ahead and drew out this chart right over here. So when you're going through figuring out whether it's the null or alternative, you can look and say, okay, the null is going to be if something is equal, less than or equal. Now that's really important. It has to be less than or equal in the wording, or greater than or equal in the wording. So that's your null. And then your alternative is whether or not they're not equal. So this is just a they're not equal statement. If they're greater than or if they're less than. Those are your alternatives. So when you write out your claim, you then kind of look at this chart and say, which of these is it? Depending on which one it is, then that's your type of hypothesis, your alternative versus your null hypothesis. For which tail is being tested, I forgot to draw that on here, but what you would want to do is look at which direction. First of all, for the tails, you always look at your alternative hypothesis. So when you're trying to determine which tail is being tested, always, always, always look at the alternative hypothesis. Do not look at the null hypothesis. Now, if it's a not equal alternative hypothesis, then you're going to have it be two-tailed or both tails. If it's a greater than, then it's right-tailed. And if it's less than, then it's going to be left-tailed. So not equal is both tails or two-tailed. Greater than is right-tailed, and less than is left-tail. So that's how you figure out which tail is being tested. It all has to do with the alternative hypothesis, but you still might end up with a null hypothesis. And then what you do, so let's say your null hypothesis is that they're equal. What you do is you come and look at the complement of the null hypothesis, which is your alternative not equal, and then that's how you would figure out which tail it is. So even if you have a null hypothesis for this step 2A that's equal, you would just look over here right across the chart at what it is for the alternative, and that's how you would base your tails. Okay? So then, and we'll get to the reject support thing in just a minute. So then we're going to calculate an appropriate test statistic. We've already pretty much done this, but we're looking for our z, and it's equal to our point estimate minus the null value. Now, the null value is always what's going to be in your claim. So if you're trying to figure out which is which, just go back to what was my null value. What did I say was the value in my claim? So whatever value is in your claim, that's going to be your null value. Now the other value is probably going to be your point estimate, and that's what you're comparing to your null value. Then this is your standard error down here, and that's just basically the null value. Also, the other thing, all of these are in decimal. Do not use percentage. These are all in decimal. But then what you're going to do is for the point estimate minus the null, and then it's over your standard error, where your standard error is that null value times 1 minus the null value over the total sample size. You then determine a p-value associated with the test statistic using the probability calculator. So if you remember, here's the probability calculator is right there. So there's your probability calculator. That's what we're going to be using to determine the p-value. So sorry, just wanted to pull that one in there. Is there enough evidence? When you get asked that question, the only thing you look at is the p-value. Is the p-value less than or equal to 0.05? Then there is enough evidence. Is your p-value greater than 0.05? There is not enough evidence. When you go to make your decision, do not look at the p-value. It doesn't matter what the p-value is when you make your decision. Your decision is completely based on whether or not you're using a null or alternative hypothesis. So you remember up here where I had reject support? In step 2, if you determine that you're dealing with an alternative hypothesis, then the only option here for step 6 is that you have to support. You have to. It doesn't matter what the p-value is, you're supporting. Now, if you determine that you are dealing with your null hypothesis, you have to reject. No other option, you have to reject. So just right there, stop, do not pass go, do not collect your $200. If you've got a null hypothesis, you have to reject. If you have an alternative, you have to support. The p-value does not matter. Nope, doesn't matter at all. Okay, so I'm going to go ahead and stop the video here for that one, and then I'm going to go ahead and go through the rest of these problems, these examples.